Hello there, are we live? Okay, we are. Good. So yeah, today I just want to continue working on our little project there. Just trying to actually remember where are we and what have we done so far. We've definitely added a button handling, as we can see here. So we can select options and then we can display what we want. So this is what we done the last time. We are handling the buttons in the using the AXTI interrupts. Yeah, and we're just printing it in here in our main loop, which is our idle handler. So definitely what I wanted to do today is add is to use the RTC peripheral, real-time clock peripheral, to implement like a little watch functionality that we can display on the screen. Yeah, so I guess let's just start doing it. So again, we start from checking it out, the examples. The Brave browser, I really want to love this, but it's quite difficult to love it, to be honest. Whenever I have multiple windows open, they just start lagging horribly. Actually, I don't need this here. All I need is just to keep an eye on the Twitch stuff. There. So that should, be faster. So let's have a look at the Rtc example that hopefully we can quickly just grab and use. We definitely can use this. So we need to initialize this. Okay. We have the DP, device peripheral, for that. Again, DP. Those are known shenanigans with the rest analyzer. This is DP and our power. That's our backup domain. And this is DP. And we need to import our RTC. Okie. We already use RCC elsewhere, aren't we? There it is. So we don't need this here. And there it is. And then once we have this, we can quickly check it by adding it in here. RTC, RTC, like that. Then we need to add it here. And then we can use this in our main loop. RTC. And go like that. Boom. And then that means that somewhere between here and here we can just display it on a screen somewhere. And we can probably reuse our text variable. So RTC log somewhere like that. Yeah, so let's write our text. Boom. RTC, and then display and print text our text, and we will display this 10 pixels away from the edge, and let's say maybe 80 pixels down. Boom, and this is R, and we need current time. And yes, boom. Okay. Let's just load it quickly and see. Okay, so by default it fires every second, and it just basically returns the content of its 32-bit register, I think. So if we'll check the docs, so that just gives us like a very minimal support for the RTC. Just this, and we're using current time, so that gives us U32, the current counter. So that it just read whatever it was there currently. So if we want something more specific, we need to set it to something. And then we can specify the alarm or set an alarm to a specific time in the future, and then that can trigger an interrupt. And for example, we can play our alarm cat song, for example, or whatever, if needs be. So, okay, that was quick and nice. So I'm thinking now that maybe this needs a little bit of a cleanup in that case. So that we don't have all of this mess in here in our main loop. So maybe okay, so what do we have here so far? So we have our three views that we swap like that. We have our confirmation. How do we trigger that? So the confirmation is... okay, we just set it up directly within our loop in here. Okie dokie. So I'm actually thinking that we should probably clean this up a little bit in that case. So probably let's have like a single screen where we show all of our measurements, and then the next screen is going to be our clock. And then, for example, once we press the button, we go into our edit mode or something where we can set the clock, where we can set the time for a clock. So I think that we will either need to add a fourth button, because we will need like left, right, a navigation, confirm, and then clear, as in cancel or something like that. So we can do that at the fourth button, or we can take our enter key, which is this one, I think, and we can implement you know, like a short button press and a long press, possibly. So maybe let's do that, and in this way we actually have 4 different buttons with just 4 physical buttons. So we will have the long press, short press, and then left, right directional key. Okay, so maybe, yeah, maybe let's start from that. So for that, we have our buttons. Yeah, so we will need an enum, and we will need pressed button, I guess, button. So we will have left, right, short press, and long press. Right? Yeah. Like that. Okay. So we have our timer now. So for that, so we will use this timer to count for how long is the button down, and if it's above a certain duration, we consider it as the long press. Okay, so for that we will need a counter. Okay, so we start to have plenty of those here, so we will need to have a look at that as well, because this is getting slightly messy. Okay, so let's have a pressed button, which is a pressed button, and we will need a press counter, which is going to be U8. It doesn't need to be any larger than that, because we will count the number of seconds it's pressed, so it should be enough. What was it? Init 0, init 0, like that. And pressed button, I guess we want to do this as well, which will be none. I think we did something similar the last time, but we got rid of this. So pressed button. Okay. Okay. So now here we need to count the presses. Press counter and context resources. Look, all it will do is just increment it constantly. So pressed counter and then pressed counter, like that. And we will need to count this as well in here. Yeah, so we will also get rid of the menu from here, because there's no need for it to be polluting the interrupt handler. Yeah. So I guess we can do it like that. So those interrupts. So the enter is raising, falling. So that means it triggers the interrupt twice. So it's triggering it on the raising edge and the falling edge. But in the interrupt handling routine, we are checking, that's why we're checking it in here explicitly for if it's low. So I think we will leave it like that, because then we can, on the falling edge, which is when we press the button, we will reset the counter, and we will reset the counter, and then while we hold it, the timer interrupt is going to be incrementing the counter, and then we will read that counter again once we put or release the button. So then the rising edge will trigger the next interrupt, and if the counter is sufficiently high, that means that we have a long press. And so that means then that we can get rid of this and then trigger those buttons. We will only trigger on the falling edge. So here, enter, blah blah blah. What we want is to press counter. Like that. And now we still need this. PC, and then PC. So we will reset it like that. So actually, let's remove this from here. And we will need the nested if, I guess. So enter dot is low. So if it's low, it's this. If enter is high and the PC is larger than 3, what am I doing? It's else if is larger than that, we need the buttons as well, which is the pressed button. Pressed button there. So we need the like that. And press button. So pressed button equals, so if it's enter and it's longer, we have a long press, else if enter is high but PC is less or equal than 3, we have PB short press. Yeah. So get rid of the menu. And here. Okay, and then in here, now it's PB equals pressed button left and PB equals pressed button right. What is that? Oh. It's not found. Okay, that's because we're being silly. There. Okie dokie. So, okay, so let's test this in a second. So in here, instead of our RTC now, we will check our buttons and which one is pressed. And we just need to add this here. Okay. Press button lock. Press button this. Yes, it doesn't, but it's fine. Boom. Okie dokie. So what do we have here? So we have none, left, right, long press, That's not right. Let's check why. Oh, that's because I assumed incorrectly that this interrupt fires once a second, but it doesn't. So once a second is better. Yeah, so actually twice a second. Like that. So what has actually happened, it's fired so many times, 50 times a second, and it's ramped up our button counter. So left, right, short, short, short. Long, short, long. Okie dokie, more or less. We still have a problem with our buttons, button debouncing. We're gonna have to fix that as well. Okie dokie. So now, okay, so now I actually want to clean this up a little bit. So in here, so basically I just want to turn this into a little bit like a game loop. So in here we will like update our buttons, I guess, and then somewhere here we will update the screen. Yeah, I guess. So the way we have it in here is display. So we have our menu item, menu, so that's how we've done it the last time. Render tab, blah. So in here we are actually passing the menu. So the way I think it would be better to do this I think it would be better to just move the display into the menu. And then these are going to be our top level object, and we will just simply expose an API like we do in here, backward, forward, blah, blah, blah. And then based on the, confirm, blah, blah, blah. And then based on the state, it will just display everything once we call the let's say, display update method or something like that. So I actually think it would be better to just take and move the display in here. So display is a display. So then we will need to take a display here. We will own it. And in that case, the menu item, we will only have like measurements, measure, we will have our clock, our watch, like that. Yeah. So yeah, a measure and a watch. In here and a display in here. I guess. So then this is not really a menu. It's going to be essentially our GUI. Like that. And then those guys, those are the views. So it's like on your mobile app. Each of those is a view. There. There. So then that's a view as well. Yeah, that's all there is, I think. And then this is measure. Measurements, and then this was what? Clock, no, watch. So then this is not a menu item, it's a view, like here. Okay, so same in here. So actually, let's not worry about this then, because we will just take it, just do it here. So we will so function print measurements. So print measurements, and we will go print clock, like that. and maybe a print error, I guess. Because that proved to be quite useful to be able to show the error. Like that. So then this is oh yeah, and we need to print that header as well in here. Print header. So then we don't need to pass in any menu items because we will have access to all of that. Okay, this actually is going to be all mutable, I think. We'll see. So no, what is it? So print header. So render top header. Yeah, so display doesn't have to know about view actually. All it needs is a text. So print header, so so much self and current menu item, and then if it's view measure, the text is measure. And then if the view is watch, like that, and then self dot display dot render top header. All it wants then is a text. And so text, which is string of view (16), I guess. Like that. So then write measure. God damn it. Ah yes, for that we need heapless and all of that. So actually I won't need that. All I need is here the text and for that is measurement. For that it's going to be a clock, because I think watch is itsy bitsy misleading. Like that. Yeah, render blah blah blah. So we will fix that now, because It used to expect this, but now we can just simply pass a static string. Or actually, yeah, a string slice. So text. And you don't need this, you don't need this. Boom. Oops, this. Yep. Like that. And 27, what is it? Oh, that's from mine. Yeah, we'll fix that in a second. Okay, so I like that. So then print clock and print measurements. Okay, we'll get to this in a second. So yeah, we won't need any of that now. Boom. And then that's not it, because then what we need is initialize the menu correctly, but it's not a menu anymore, it's our GUI. So this is not a menu, it's a view, yes. It's a GUI. Unused. So that means then that we won't have display here anymore. Like that. We will have this. So then we will initialize the GUI here. So let GUI equals new with a display. Boom, like that. And then no menu. Because this is a GUI and no display. And then that can be cleaned up. And this is a GUI. Now this. Oops. Like that. So this is then here. That's how it was it? Print header, yeah, print header. Boom. There. So we print header So that means we won't need this anymore. This, and this. And then here what we have is GUI print measurements. Yeah, and GUI dot print error if any. So actually we can keep it like that. Yeah. Okay. And then the next part is GUI print clock. Print clock like that. Okay, I think I like that slightly more. Okay, so that means that we need to pass in the measurements. In here we can pass the error, and here here we will need to pass in the RTC. Not sure if that will make a difference. Can I just like this? And just do it like that. Okay. So the measurements now. So we were using the BME 280 crate. So the measurements. So it's just a struct with a couple of floats. So the thing is that I'm not sure if I want to know about the measurements here. So I think, like, instead of just importing this in here, jeez, I'm sick of writing that word. So maybe it will be just okay to pass in them like that. Yeah. So at least then I don't, the display doesn't have to know about the measurements. Because what else can be here? Like none of this will allow me to I won't be able to take any trade or anything like that, just to be able to extract those exactly. So I think it's better to just destructure it in here when we pass in it. Measurement. So then I can just not text. Add bytes. Like that, and then write, boom, so temperature is this Celsius, and then the humidity is whatever, 0.2%. And then the pressure is whatever pascals. That, and then self.display print text is text, and then we want it at 0, 30. Oh yeah, and we forgot to pass in the so stats.0, stats.1, and stats.2. Because there is no heapless. Yeah, because we need write as well. Use core. This. Yeah. Okay, so this will need to know about the RTC. So I guess we will need to write some sort of a wrapper around RTC anyway. Something that will allow us to provide us a human readable time and stuff like that. So some sort of watch. RTC is RTC. Like that. So then just watch, and watch will give us some get time, something like that, and that will be human printable, I guess. So watch, so our function get time self, that will return time. So it will be self.rtc dot, what was it, current time. So time value, and then we will just return the time value in time. Okay, and that will be time, which will have hours, that will have minutes, and that will have seconds there, and it will implement core convert from that gives us U32. So U32 for time function from, so value U32, so hours is what the value divided by this, let minutes is value modulo 360 0.00 divided by 60. And then let's seconds is value modulo this modulo 60, and it gives us self hours, minutes, and seconds. As you wait, there. So watch get time. Time. So then we need the core FMT and display for time. So then what's it, format there and core. Okay. Yeah, and so we will then just write have this boom, boom, and boom, and it's going to be self hours, self minutes, and self seconds. Okay, that's a lot of boilerplate. So that means then all we need is just that text string. So yeah, 16 bytes. Boom. Right. Text. Boom. This. And then watch dot get time. So then self dot display dot print text. Yeah. Text. Whatever. 10, 30. Boom. So that means in here we need to swap the RTC with watch. So that's a watch. This is unused? Yeah, it would be unused actually, because we handle most of that internally, and that shouldn't be needed anywhere either, and neither this. Oh my god, this is getting so clean, so maintainable. Where do you have the RTC? Here. So here we need let watch new RTC owned, boom, and then it's not you, it's watch. Did we edit it here? No, we didn't. Yeah, so like that. Yeah, this resource has not been declared. Yeah, okay. Which is this, because it's watch now. There. And there. So then all that is left is this. So how do we do this? What sort of error is this? So it's not measurements. It's just okay, this is taking well longer than I was expecting. Forgot to change this. Watch. So then here, I guess we can just do this the lazy way, and we will just take error, which is going to be the book. The book, and then this. What's going on here? Jesus. There. Instead of this, we will have our error. like that, and this needs to be boom. Okay, and as well here. Okay, what's more? Print header. Yes. This was nagging me at the back of my head. And use result, yes. Come on, I want to see green. There it is. Okay, so we have that. What is wrong here? Boom, nothing. Exactly. Yeah, so here we will need to update the buttons. So we will press the button, press 1, and then we will match on it. Match on PB. So if its pressed button is left, as before, we go GUI.lock, GUI g dot what was it? Quartz. What was it? Acquired, yeah. Then, if the pressed button is right, we go GUI.lock, GUI forward. So that will allow us to navigate the different screens. And then we leave this for the time being. Let's see where we are now. We forgot this. Okay. Boom. That's looking finished. That's looking green. I like that. Okay. So actually in here we have press button lock. Okay. I think it's better to do this in here because we're gonna have to update that press button. So let's do it like that, like this, and and then just do match on PB. There. Because if we press the button the way we have it right now, because we don't look on the raising edge, oh, hello toggle bit. It's going fine. Just working on a little bit of embedded Rust stuff. Yeah, so because of that, that will never become none. So it will look like it's constantly pressed. So I think here we're going to have to set it as none. Like that. Boom. And then, so actually no, it's pressed button lock. So then we set it to none. So that's our way to just reset its state. And we're gonna have to do this for all actually. Like that. Boom. And what's going on here? Press buttons. So we just need to make them. We just need to derive the copy clone stuff. Copy clone. No, we've done it in the wrong way. We need to do this here. There. Like that. Okay. So now okay, now we should be able to test it, I guess. Okay. Okay, that's not good. None of our buttons are working and they're actually crossing stuff. Okay, let's see what's going on here. What is going on? Not sure what's going on here. Oh. Hold on. We changed this, but our logic that looks after not going out of bounds is still untouched. Yes. So that's what it is, because we haven't adjusted the we haven't adjusted our bounds, because right now we had 3 elements in the menu, now they're just 2. So is there other silly mistakes that we're doing here somewhere? Yeah, I think that is fine. Okay, that's fine, that's fine. Let's check. Continue. Oh, again, that's us being silly again. So this is fine, the buttons are working now and they're swapping stuff. Our problem is in here actually. So the problem is that right now it's all of this is being displayed at the same time. So we want to display the measurements only if we are in the measure view. Measure equals self blah blah. Oh, like that. And we want to print the clock only if our view is watch. Like that. And the error will happen only during this screen. Error, I don't care. Ah, jeez. Okay, I think it should be better now. Uh-oh. We run out of flash. Dun dun dun. We physically run out of space for our code. And we run out our data. 1 4 1 4 1 4. We're gonna have to shave off every byte that we can. Okay, we will trump those temperatures. Temperature, realistically it goes to 100 degrees. Humidity, it physically goes as far as 100, so we're fine and we don't care about the decimal part of the pressure. Yeah. Oh, will that help us? We need to trim this as well. 52. Boom. Boom! Just riding on the edge of that flash. Okay. But this seems to be as far as we go. So measurements and clock. So you can see that it's actually changing, but it's overflowing because we need to clear or re-render the entire screen. But I honestly don't know if we're going to have a space for that. So we want to do this. We will try to re-render. That'll help. And we will re-render any oh, come on. We will re-render anytime there is a change. So here and here. We will need a way to clear it. So actually, yeah. So, oh Jesus, pop function clear. Not self. Self dot display dot clear and then the color. And so RGB, and we will re-render as black. So then here it's display dot clear. And self dot re-render false. We will also have to do this here. So actually here we go. And in here. Oof. Still within that flash. We're still fitting in. Boom. How about this? Okay, so our clock is horribly malformed. It's hideous to look at. So boom. 02. That's what it was. Yeah, just to pad some zeros. Okay, that's a bit better. So I think it's a good time to take a break now. It's been 2 hours almost. We pushed this forward a little bit. We added the real-time clock stuff. We refactored our GUI, our menu. So I think our next step is going to be buy a bigger processor, I guess. But no, it's not all bad. What is it? There is this stuff called what is it? FMT, micro FMT. It's this. So this gives us a macro, same that we're using for formatting our output, but it's heavily optimized for embedded and heapless stuff, no STD stuff development, and it gives us the equivalent of debug and micro debug and micro display traits that we can implement and use this instead. So I think this is what we're going to do the next time. So hopefully that'll save us some space on in the flash. So what's the cargo size? So right now we are taking 40K. We're taking 40K out of 64K. So okay, it's not bad. We can still some space to go. But we also have a bit to implement, because we want to add some sort of like edit functionality so that we can set our clock. Yeah, and after that we'll see where we are and what other functionality we can add to this. Okay, so talk to you guys next time.